9.5.1, it's called binomial coefficients. And we're going to talk a little bit about why they are coefficients of binomials a little bit when we get to 9.5.2. 9.5.1, we're really just looking at how to evaluate this number, which is called n choose k. So 9.5.1, rather than calling it binomial coefficients, I'm going to call it n choose k, which are binomial coefficients, but we don't really know what that means just yet. So how to evaluate n choose k? That's this number here. This number that's represented as a parentheses with two letter numbers like that. So this is 6 choose 4. And what that really is, what that number is, it's a counting. It's a counting is if I have a group of 6 items, 1, 2, 3, 4, 5, 6, and I need to choose 4 of them to go into another space. So, for example, let's say we have a group of 6 students, and 4 of them get to win a prize. So I'm going to go into like a little study group. So maybe I'm going to choose 4 of them to go into a certain study group. So how many ways can I choose those 6 people to go into this study group? Well, let's see. I'm going to put 4 spots in my study group, and my first spot, I'm going to pick this guy and put him right there. How many ways could I have chosen him? I'm actually going to do it a little different. I'm going to lay it out like this. That's my study group. How many ways can I choose that first guy? Well, there's 6 choices, and I pick 1. So there's six things to choose from. Okay, so he's already in the group, and then I want to choose someone else. So I need to go back to my group, and I only have 5 people in my group now. So I have 5 options, and there goes a 5. And now I only have 4 people left in the group. So I pick one of those, and I had 4 options for him or her. And then for the last one, I have 3 people to choose from, and I choose this one. So I had 3 options. So to find out how many ways can I choose those 4 people out of a group of 6, I just multiply these numbers together. And that gives me, it actually doesn't matter what it gives me. So for now, let's just look at that. It gives me the product of those 4 numbers, gives me the number of ways to make this group of people, this study group, in this order. But let's think about that. That's actually the same study group as if I had chosen 5, 4, 6, and 2. Oh, and it's the same study group if I chose 2 and 6 and 4 and 5. The order that I choose them doesn't matter. So I have to think about how to unorder them. Okay, so now let's talk about this formula and how what I'm saying relates to that. So if I were choosing 6 people out of the group, then I would have that n factorial. 6 times 5 times 4 times 3, that's almost 6 factorial, right? Except if I do 6 times 5 times 4 times 3 times 2 times 1, I don't want the 2 and the 1. So how do I get rid of that? I get rid of that by thinking, okay, well, how many people were left in the group after I was done? There were 2 people left. That's the n minus k. So that's the 6 minus 4 factorial. So that gives us the 2 factorial, which is the 2 times 1. And then we have to think about how to take away the order. So the order, to say order doesn't matter. How many ways are there to order it? There's k factorial, or in this case 4 factorial. How many ways are there to make this study group? There's 4 factorial ways. So I want to divide by 4 factorial to say order doesn't matter. So then that gives me the 4 times 3 times 2 times 1. Okay, so that's how we get this formula. N factorial, we choose our, we're choosing from n people, and then we have this many people left over after we've chosen, and we have to make sure that order doesn't matter. So that's what that n choose k means. You don't need to reinvent that. I just want to give you an idea of what it means. So when you can look at it, things make sense. So for example, I want you to see this conceptual sentence. Understand why n has to be greater than or equal to k in order to define n choose k. So if my group n was smaller than the size of the study group, then I wouldn't be able to make the study group. That wouldn't be possible. So the original group n has to be bigger than the smaller group. So n has to be equal to or greater than the smaller, the k. So n is greater than or equal to k. Okay, so now I'm going to have you go to example 1 of our textbook and see how to actually apply that formula to find these 4 values. And while you're doing that, I want you to think about what it means in terms of choosing k from a group of n, choosing 4 from a group of 6, choosing 5 from a group of 5, choosing 0 from a group of 4, and choosing 9 from a group of 10. Okay, so this is on page, oh, I didn't write the page number down. Page 730 of your book. So pause my video, go watch that example. She's going to show you how to use the formula to make these evaluations, and I just want you to think logically. Does it make sense that if I have a group of 6, choosing 4, that I have 15 ways to do that, and so on. All right, so watch those recordings and then come back here and we'll try some of these together. All right, so we saw example 1. So we used the formula, and we're going to do that again with 2, 6, and 8. On this section, you're doing every other odd. So I got some evens here for us to try together. You actually watched, in example 1, you watched 4 examples already. So before we do that together, I want you to go ahead and pause this video and try these 3 on your own, and then you can come back to the video and see how you did. Okay, so number 2. Here's our formula. N is 8 and k is 2, right? It's always n choose k. N choose k. So that means we have a group of 8 and we have to choose 2 things out of it. So 8, our formula is n factorial, which is 8 factorial, over n minus k, which is 8 minus 2 factorial, and then the k, which is the 2 factorial. So I just plugged the n and the k into this formula. All right, simplifying that, I have 8 factorial over 6 factorial times 2 factorial. I'm going to write that out, and I get 8 times 7 times 6. I could keep going. In fact, I will. I'll go ahead and just keep going. I'll just write it all out. But I do know that as soon as I get to that 6 factorial, I'm going to write the 6, the 5, the 4, the 3, and the 2, and the 1 again, and I'm going to cancel those. And I also have the 2 factorial, so that's a 2 times 1. So I can cancel the 6 factorial here with part of the 8 factorial there. I can also reduce the 2 and the 8. 2, taking out a factor of 2, I get 4 over 1. So now I just have 4 times 7, which is just 28. That's my final answer for number 2. I'll write that on top. So 8 choose 2 is 28. So that says if I have a group of 8 and I have to choose 2 out of that 8, there's 28 different combinations that I could choose. Okay, so now I'd like you to try this other example. Find 8 choose 6. And you can pause the video and see if you can find that on your own. Okay, let's see how you did. So 8 choose 6 means I have 8 factorial over 8 minus 6, which is 2 factorial, and then 6 factorial. And if I spread that out, I get 8 times 7 times 6 factorial. This time I'm not going to spread out the 6, 5, 4, 3, 2, and 1 because I know I'm just going to divide it by that 6 factorial that's in the denominator anyway. And then 2 factorial is just 2 times 1. So my 6's cancel. My 2 and my 8 can reduce by a factor of 2, and I'm left with 4 by 7. So, looks pretty familiar. We just did this. The numbers came out exactly the same for 8 choose 6 and 8 choose 2. So let's think about what choose means. What does n choose k mean? If I have a group of 8, 1, 2, 3, 4, 5, 6, 7, 8, and I choose 2 of them to go into my little study group here, then isn't that really the same as choosing the 6 people who don't get to go to the study group? So choosing 2 is exactly the same as choosing whatever 8 minus 2 is, which is 6. So choosing who gets picked is the same as choosing who doesn't get picked. So these are going to be equal. And I want to point that out because we are going to be using that. We will be using that equalness later for some symmetry in our binomial expansion. Okay, so note that these are equal and it's not a coincidence. All right, now let's move on to number 6. Get a different color. It's looking a little crowded here. Okay, there's 2 ways to do 6. One, we can use the formula. The formula always works. Or you can think about it. If I had a group of 100, how many ways can I choose? 0. Well, let's do the formula. So here's my formula. N factorial is 100 factorial. N minus k, that's 100 minus 0, which is also 100. And k is 0. Remember our exception rule, 0 equals 1. 0 factorial, that's a 1. And then 100 factorial over 100 factorial is, these both cancel too. I should actually let that as a, so that's really 100 factorial over 100 factorial, which equals 1 over 1, which is just 1. So that equals 1. Now think about your choosing. If you have 100 people and you're going to choose 0, there's only one way to choose 0, and that's by choosing no one. So that is one that I wouldn't feel the need to do the formula because I can think easily about whenever I have a 0 for k, I know that that means that there's only one way to do it. So n choose 0 is always equal to 1. I'm going to write that as a rule. What color should I use for a rule? Let's do black. N choose 0 always equals 1. And I'll do a red tip box around, a study tip box. Okay? Okay. Now let's go to 8. So again, we can use a formula or we can think if it's easy to figure out. All right, our formula says n factorial, which is 52 factorial, n minus k, well, 52 minus 52 is 0, so that's 0 factorial, and then k factorial, so that's 52 factorial. Well, my 0 is 1, and then I have 52 factorial over 52 factorial, which cancels, and that gives me 1. Okay, so the formula gives me 1. Now think, if I have a group of 52 people and I have 52 slots to fill, then everybody gets chosen. And there's only one way to choose everybody, and that's by choosing everybody. So I wouldn't really need to do the formula for that one because I know another study tip that if I'm going to choose everybody, then there's only one way to do it. So that would be n, if n, and choose k where n equals k, how do I do this? If n equals k, then nk equals 1. Or it might be easier to see and think of it as nn. So that's my next study tip. So that's an always. So both of those red boxes are things that you can just remember are always true. If I'm choosing 0 or I'm choosing n, then it equals 1. Okay. So a couple things. If I'm choosing 0, I'm choosing n, it equals 1. And then the other study tip I have for number 2, I have another study tip, remember that was there's some symmetry. So n choose k is going to be the same value as choosing the guys that don't get chosen. So that's n minus k. So those will also be equal. So that's my third study tip. Okay, that wraps up 8.5.1, which is just evaluating that value of n choose k. I'm going to highlight my study tips.